Hello students, today we are going to start this new chapter, that is heat. In last chapter 3, you have learned that woolen clothes are made from animal fibers and the cotton clothes are made from plant fibers. Now in this chapter, you will come to know why we prefer to use woolen clothes during the winter season and this cotton cloth during the summer season. So students, in our day-to-day life, we come across a number of objects. Some objects are hot, some are cold, like tea, diya, they all are the hot objects. If you talk about the ice cream and the ice, they are the cold object. So, how do you decide whether the object is hot or cold? Yes, we often decide it by touching the objects. But my question is our sense of touch reliable? Let us find the answer. Take 3 tumbler of water, mark it as A, B and C. In tumbler A, put cold water and hot water in tumbler B. Mix some cold and hot water in mug or the tumbler C. Now dip your left hand in mug A or the container A having the cold water and the right hand in container B having the hot water. After keeping the hands in both the container for 2 to 3 minutes, put both the hands simultaneously in container C having the lukewarm water. What do you feel? Now you must be confused. Why? Because one of your hand means the left hand will be feeling that water hot, but your right hand might be feeling it cold. So, now your answer is very clear. It means that our sense of touch is not reliable. We need something to check the temperature of the object. Students, in the previous slide, you have seen that touch is not a reliable method to know the temperature of any object. So, student, what is temperature? Actually, measure of degree of hotness and coldness of any object is called temperature. And a reliable device which is used to measure the temperature is called thermometer. In this chapter, we will learn about 2 types of thermometer: clinical thermometer and laboratory thermometer. This clinical thermometer is used to measure the body temperature of humans and animals. The clinical thermometer and laboratory thermometer, they both are mercury based thermometer. So first of all, we will know about the construction of the clinical thermometer. A clinical thermometer is formed of a long and narrow glass tube with a bulb at its one end. This bulb is filled with mercury. The glass tube encloses a thin capillary tube. The capillary tube has a kink just above, a little above the bulb. Here in this figure, this kink is written as constriction, and 2 scales, that is Celsius and Fahrenheit scales, are shown on the thermometer. The range of Celsius scale on the clinical thermometer is 35 degrees Celsius to 42 degrees Celsius, and that of Fahrenheit scale is 94 degree Fahrenheit to 108 degree Fahrenheit. Now, how this clinical thermometer is being used? Before using this clinical thermometer, it must be washed and dry. Then 1 or 2 jerks are given to make sure that the mercury in the capillary tube has fallen well. Why? Because a kink is present in the clinical thermometer. This kink is present because this kink prevents the backflow of the mercury. So, for falling down of the temperature, we give jerk to this thermometer. Now, put the bulb of the thermometer under the tongue for 1 minute. Take it out and read the temperature. The temperature of the human body is always 37 degrees Celsius or 98.6 degree Fahrenheit. And if the body temperature is above 37 degrees Celsius, it means the person is suffering from fever. So, now coming to the laboratory thermometer. But before coming to the laboratory thermometer, we must know some precautions while using the clinical thermometer. That thermometer must be washed properly with some antiseptic before using it. The second thing is it should be used very carefully because it contains mercury, and mercury is poisonous. And third thing is, while giving jerks, one should take in care that it shouldn't hit any object in the surrounding. Then, while taking the thermometer inside the mouth, don't laugh or talk or don't do any actions, because this can lead to the breakage of thermometer, and which may release the poisonous mercury into the mouth. And note the reading in the clear light. Now coming to the laboratory thermometer. This laboratory thermometer is actually the main difference between the clinical and laboratory thermometer is this laboratory thermometer lacks kink. No kink is present in this laboratory thermometer. It consists of a very thin capillary tube of glass which is surrounded by thick and supportive glass walls. The upper end of the capillary is closed after evacuation, and the lower end is drawn into a delicate bulb-like shape with a thin glass tube. The laboratory thermometer is generally used to measure the temperature ranging from -10 degrees centigrade to 110 degrees Celsius. So, this stem of thermometer has marked as horizontal lines to read the particular temperature, and these marks are also known as calibrations. So, some precautions are also there to use while using the thermometer, laboratory thermometer. The bulb of thermometer should be kept vertical and in contact with the object whose temperature is to be measured. It should not touch the bottom or the sides of the container. Second one is, the reading of temperature should be taken without removing the thermometer from its position. Why it is so? Because there is no kink. If suppose you will take out the thermometer from any solution or any substance whose temperature you want to measure, if you will take out the thermometer, then the mercury will fall down and you will not be able to read the temperature. So, these are some of the precautions which you have to follow while using the clinical thermometer and the laboratory thermometer. There are 3 scales of measurement of temperature. These are degree Celsius, degree Fahrenheit and Kelvin. On the Celsius scale, the freezing point of water is 0 degrees Celsius, whereas its boiling point is 100 degrees Celsius. So, this scale is calibrated from 0 degrees Celsius to 100 degrees Celsius. On the Fahrenheit scale, the freezing point of water is 32 degree Fahrenheit, whereas its boiling point is 212 degree Fahrenheit. So, this scale is calibrated from 32 degree Fahrenheit to 212 degree Fahrenheit. And here are some conversion formula for converting the Celsius scale into Fahrenheit scale and Fahrenheit scale into Celsius scale, and the last one is used for converting the Celsius scale into Kelvin scale. So students, before coming to know about the difference between the clinical thermometer and laboratory thermometer, we should know the similarity between the clinical thermometer and the laboratory thermometer. They both are mercury based thermometer and they both are used to measure the temperature. Then why this mercury is used in this thermometer? This mercury is the only metal which is liquid at room temperature, and it has very high boiling point and it is very sensitive to heat. Means if suppose a very small amount of heat is given to the mercury, it expands very efficiently. And one more thing is there, it is shiny in nature and it doesn't stick to the glass tube also. That's why this mercury is used in this thermometer. Now coming to the differences, the clinical thermometer is scaled from 35 degrees Celsius to 42 degrees Celsius or from 94 degree Fahrenheit to 108 degree Fahrenheit, whereas the laboratory thermometer is generally scaled from -10 degrees Celsius to 110 degrees Celsius. And in clinical thermometer, mercury level doesn't fall on its own as there is a kink present, so it prevents the fall of mercury level. But in laboratory thermometer, the mercury level falls on its own and as no kink is present over there. The third point is the temperature can be read after removing the thermometer from armpit or mouth. But here in laboratory thermometer, it is read while keeping the thermometer in the source such as liquid or anything. Fourth point is to lower the mercury level, jerks are given. But in laboratory thermometer, no jerks are needed. In clinical thermometer, it is used to take the body temperature, while laboratory thermometer is used to take the temperature in laboratories. Now we will start this new topic, that is transfer of heat. Actually, this transfer of heat always takes place from hotter object to a colder object, or we can say from a body at higher temperature to a body at lower temperature. So, whenever the two bodies at different temperature come in contact with each other, the heat will flow from the hotter part to the colder part. There are three ways of transferring of heat. The first one is conduction, then convection, and then radiation. First of all, we will discuss about the conduction. Conduction is the mode of transfer of heat in solids. In this process, the heat flows from the hotter end to the colder end of a solid object, and the process is called conduction. Now let us see how this conduction process takes place in solid. The particles of solid are very closely packed with little spaces between them. All the particles vibrate at their fixed position. When the material is heated, the particle starts vibrating and bang into the particles next to them. Thus the heat is carried from one particle to the another just like a relay race, and so the heat is transferred from the hotter part to the colder part. And now coming to the next thing, now some objects can pass heat very easily through them and they are called conductors, while some materials don't allow this heat to pass through them and they are called insulators. And very common example of insulators is wood, plastic, rubber. Yes student, and the example of conductor is metal. That's why the metal is used to make the saucepans for cooking food. Why? Because they are a good conductor of heat. So in this way the conduction takes place. Now coming to the next process, that is convection. Convection is the mode of transfer of heat present in liquids and gases. In this, the heat flows from one part of a fluid to another by the movement of fluid particles itself. Now students, we will learn this process in more detail. In convection, the particles of a fluid near the source of heat get energy, become light and rise up to the surface of the fluid. Their space is occupied by the colder particles at the bottom from the sides. In this way, a fountain-like circulation pattern is developed, and this is called convection current. It means the particles which are present in the fluid nearer to the flame, they will become hotter and will become lighter and will rises up, and the particles which are on the upper surface of the fluid, means it may be water or it may be liquid or it may be gases. So the colder particles are heavier one, so they will come down. So you can see a circulation pattern in the fluid in the case of liquid, because the colder particle will come down to take the space which is being left by the this warm particles, which become lighter and rises up, and in this way the convection current develops. Now we will discuss about some of the convection currents in nature. You might be knowing about the sea breeze and land breeze. First of all, we will discuss about the sea breeze. During the daytime, the land gets heated faster than the sea water. The air above the land becomes hot and rises up. The cool air from the sea rushes toward the land to occupy the space left by the hot air. The convection current from the sea to the land causes sea breeze. In this way, the sea breeze develops. Now coming to the land breeze, during the night time, the process is reversed. The land loses heat faster than seawater, or we can say that seawater cools down more slowly than the land. The air above the sea is warmer than that of the land. Thus, the warm air above the sea rises upward. The cool air from the land rushes toward the sea to occupy the space created, and the convection current from the land to the sea creates land breeze. This phenomenon of sea and land breeze makes the climate of the coastal areas mild and pleasant. Now students, coming to the next process of heat transfer, that is radiation. We feel the warmth of sun when we are outside. Why? Because we get energy from the sun in the form of heat. Have you ever wondered how this heat energy from the sun reached to us? It is not possible by conduction because this process takes place only in solids. Also, the convection process is not possible because there is no medium in some parts of the space between the earth and the sun. So, there is another process of transfer of heat which can take place without any medium, and this process is called radiation. So, the mode of transfer of heat from the distant sources in the environment without requiring any medium or contact is called radiation. In this process, heat flows in the form of waves. So, we can also define radiation as the spread or flow of heat in the form of heat waves. Then, coming to the one figure which is given in this slide, that man is holding a container and he is boiling the water. He is boiling the water. So, this container is getting hot and the handle is getting hot due to the process of conduction. This liquid is becoming hot due to the process of convection, and the heat which is coming on the side of this flame is due to the process of radiation. And in this and in another figure, you can see how the sun heat reaches to the earth by the process of radiation. Now, one thing I want to add, when this radiation falls on any object, the part of it gets reflected and a part is absorbed and some part of it may be transmitted also. So, the temperature of object increases and it becomes hot due to the absorbed part of the radiation. But the amount of heat absorbed by different object is different. Like that, the darker object absorb more amount of heat in comparison to the lighter clothes. So, we prefer dark color clothes during the winter season because they will absorb more heat from the surrounding during the daytime and we will feel warmer. And during the summer season, we wear light color clothes because they reflect most of the heat falling on them. But students, these dark color clothes are good radiators also. Now coming to the next point, that is wool. Wool is a poor conductor of heat. Why? Because small pores are present on the wool surface and the air is trapped between the wool fibers that prevent the flow of heat from our body to the cold surrounding and we feel warm. So, we prefer to wear the woolen clothes during the winter season. Thank you, students.